Today's motor vehicles are designed to provide exhaust emission control along with good drivability. Harmful gases in the exhaust are greatly reduced by the effects of engine design features and built-in emission control systems. These systems are designed to operate with little attention, but sooner or later, servicing and adjustments are needed to make sure that everything is operating properly. The required maintenance services listed in the service manual are intended to keep emission control systems and related engine components in good operating condition. All are closely interrelated, so they must operate properly and in balance to be effective. Although all the items on the maintenance schedule must be checked and in good condition, our main concern here is the why and how of ignition timing, idle speed, and idle mixture adjustments. Three factors which have an important effect on the amount of hydrocarbons, carbon monoxide, and oxides of nitrogen in the exhaust. Hydrocarbons is the name that covers a large group of chemical compounds made up of hydrogen and carbon. Gasoline contains several hydrocarbons which, combined with oxygen, will burn when ignited. In an engine, intake air provides the oxygen required for gasoline combustion. If the air-fuel mixture is over-rich with fuel, there's not enough oxygen to burn all the gasoline in the combustion chamber. As a result, some unburned hydrocarbons will go out the exhaust. An overly lean air-fuel mixture can also result in unburned hydrocarbon emissions because the fire in the combustion chamber tends to go out before all the gasoline is burned, in effect causing misfiring. You see, where the mixture is very lean, the relatively small number of fuel particles are separated enough to keep the heat from extending to neighboring particles. If this heat is not transferred to the other particles, the fire in the combustion chamber dies out, leaving some of the hydrocarbons unburned. By comparison, with an ideal air-fuel mixture and good compression, the fuel particles are packed close together, so each burning particle passes on enough heat to ignite practically all of the adjacent fuel particles. Precise ignition timing is also essential for complete combustion of gasoline and a clean exhaust. When the air-fuel charge is ignited too soon, the fuel particles are not packed close enough to produce continuous and complete burning. If ignition is late, combustion does not start soon enough to burn all the fuel before the power stroke is complete. As a result, unburned hydrocarbons will flow out with the exhaust. The second harmful gas in the exhaust is carbon monoxide, which is 1 part carbon and 1 part oxygen. This compound results from not having enough oxygen in the combustion chamber to produce harmless carbon dioxide, which has 1 part of carbon with 2 parts of oxygen. Now let's summarize. A mixture that is on the rich side tends to increase both carbon monoxide and hydrocarbon emissions because there isn't enough oxygen for complete combustion. A lean mixture tends to reduce carbon monoxide emissions, but a mixture that is too lean for complete combustion will increase hydrocarbon emissions because the fire goes out. We'll see how this affects emission levels when we get to idle mixture adjustment. The third exhaust emission problem is oxides of nitrogen. The intake air which supplies oxygen also includes nitrogen. This nitrogen passes through the engine and out the exhaust without change where combustion temperatures are in the vicinity of 2,000 degrees. However, without some form of temperature control, brief temperature peaks of nearly 4,000 degrees can occur under some operating conditions, causing some nitrogen and oxygen to combine and form oxides of nitrogen, one of the factors in photochemical smog. In today's engines, peak combustion temperatures are held down by diluting the air-fuel mixture with controlled amounts of inert exhaust gas. Some gas remains in the combustion chamber as a result of valve overlap, while additional gas is admitted by the exhaust gas recirculating system. While exhaust gas dilution reduces peak burning temperatures, it also slows down the combustion rate and tends to increase hydrocarbon and carbon monoxide emissions. Also, the mixture is ignited later to burn as much gasoline as possible inside the engine and exhaust system. Remaining hydrocarbon and carbon monoxide emissions are cleaned up by the action of an air injection pump, a catalytic converter, or both. In addition, combustion chamber temperatures tend to increase if ignition vacuum advance takes place immediately on acceleration. This condition is overcome by the orifice spark advance control system, which delays the buildup of vacuum advance. To sum up, let's repeat and expand the point made in connection with required maintenance. Carburation, fuel distribution, and ignition timing are all closely interrelated, and therefore adjustments must be made correctly, or the only possible result will be poor drivability and excessive exhaust emissions. Before you check emission levels, drive the vehicle about 4 miles at average road speeds to stabilize engine temperatures. Begin your tests within 5 minutes after the warm-up run so the engine will not cool down and cause false test readings. For accurate idle mixture readings, the air cleaner must be in place, and on air injection pump models, we temporarily disconnect the air outlet hose and plug the connecting air tube to the exhaust manifolds. Connect an infrared type exhaust emission analyzer to the vehicle exhaust system. Install the appropriate sampling probe in the tailpipe or ahead of the catalytic converter as instructed on the information label under the hood. The exhaust system must be gas tight to produce accurate and consistent readings, so make sure there are no leaks, including the probe connection used with the converter. Incidentally, the infrared analyzer heats a reference air sample and an exhaust gas test sample equally and compares their pressure difference electronically. A rich mixture produces a greater pressure difference, causing higher indications, while a lower pressure difference with a lean mixture causes lower indications. Warm up the tester and check its calibration. Then, with the probe connected, start the engine and run it at curb idle for about 15 to 30 seconds. After the engine stabilizes, check the HC and CO meter indications. Check the meter readings against the emission control information for the vehicle. If the readings exceed these levels, timing, idle speed, and idle mixture adjustments must be checked and reset if necessary. Be sure to use an accurate tachometer. Remember that vacuum-controlled emission systems begin to operate as the throttle is opened from idle position, so be sure to keep an eye on the idle speed when making timing and idle mixture adjustments. Also remember that the distributor vacuum hose should be temporarily disconnected and plugged to prevent vacuum advance, which can cause false readings and adjustments. As we mentioned earlier, the timing must be set to specifications for proper combustion so the emission levels will not be affected. Here's what happens when the timing is advanced beyond specification limits and when it is retarded. After adjustment, retighten the distributor clamp and recheck the timing to make sure it is not changed. If the idle speed has changed with the timing adjustment, reset the idle speed screw. The infrared emission analyzer is very sensitive to air-fuel ratio changes. In fact, the idle mixture screws must be adjusted in 1/16th of a turn increments to get steady, accurate meter indications. Here's what happens after a quarter turn on one screw. Adjust both mixture screws an equal amount to avoid an unbalanced condition. Turn the screws counterclockwise in equal steps to start with a richer mixture. After each adjustment step, allow at least 5 seconds for meter response. It may be necessary to repeat the adjustment process to get a noticeable increase in the HC reading. Be sure you're turning the screws in the rich direction, because the HC reading will also increase if the mixture becomes lean enough to cause misfiring. Now, with the rich mixture condition established, reverse the adjustment direction. Turn both screws clockwise in equal steps for an acceptable carbon monoxide reading and the lowest hydrocarbon level with smooth idle. Remember that drivability may suffer if CO drops below the specified level. The speed screw must be reset if mixture adjustment changes idle speed above or below the specified setting. After resetting idle speed, repeat the mixture adjustment procedure. If the carbon monoxide level is okay, but the hydrocarbon indication is high, an equal but opposite adjustment may do the trick. Turn one screw out and the other in by the same amount to keep CO constant while reducing the HC reading. Timing and mixture adjustments should be completed within 15 minutes. Overlong idling can cause carburetor overheating and tends to form combustion chamber accumulations, both of which can make the meter indications inaccurate. You'll find that your ability to make effective maintenance adjustments improves with practice. Use care, follow the required maintenance procedure, and your customers will all be satisfied customers. The new Dodge Aspen and Plymouth Volare offer a new concept in styling and engineering for buyers who want a smaller car with a luxury comfort ride and exceptional handling characteristics.